Okay. Does anybody have any questions they want to go over?
No.
No.
I think I'm good. It's all just formulas. It's crazy formulas again. So much.
This is almost too much. I could do the other ones, but these ones are too complicated.
Yeah, it's ridiculous. It is too much.
Yeah, so much to remember.
There's no way we could remember all this stuff without notes. And I don't see how we can do 1 page of notes. There's way too many things to write down. Okay, so it said to do this part with your group. Did you guys do that part? Or are we supposed to do that? I don't know, part 3. Part 2, I mean.
Oh, I thought we were supposed to do. I didn't read that. I just always do part 2. On my own, because that's usually how it is.
Let's see. 4. I didn't do that part because it said do it with your group. So, okay, let's just open this.
Well, then I guess we can do it together.
Check the requirements. Oops. Requirements is it just has more than 10, right?
No, there's formulas for it.
Oh my gosh. Oh. Is it the requirements for the confidence interval?
Yeah, but this one's different.
But the N1 times P hat 1 is greater than or equal to 10. Is that it?
Yeah.
Okay.
Yeah, so it's N1 times P hat 1 is greater than or equal to 10, and then N1 times 1 minus P hat 1.
Yeah.
Right.
But you also have to do it for N2 and P hat 2.
Okay. Okay. And okay. N1. So we're doing the women is 296 times we have 1. $296 P hat is two, 8, 3.
Okay.
Okay. N1 times P hat 1. That is 296 times 0.21283. $62 is greater than 10. And N1 times 1 minus 2, 1, 2, 8 minus 26. 233 is greater than 10. So we're good on the women. And now the men into X. 27. To 251. 27 is greater than 10. And one oh 756. Times 251. 224. Okay, so the requirements are yes. Null is HO P1 equals P2. And HA is not equal, right? P1 not equal to P2. Okay. This is the craziest.
I know.
That whole, oh my gosh. Okay, test statistic. Gosh. C equals P hat 1 minus P hat 2. It's so crazy. It's going to take 20 minutes. Gosh. Okay. Did I write it all down wrong?
Oh man.
Test statistic L is Z and is given by oh, here it is. So it's the Z, okay, equals P1 minus P2 minus P2 over square root P hat 1 minus P hat plus 1 and 2. Okay. P hat 1 is 0.21283, 0.10756. minus. Okay, so what is P1 then? If we have P hat,
It's 0.
how is it
P1
0?
minus P1 minus P2 is 0. That's what it says in the reading. Because that's what you're trying to figure out if P1 equals P2 or not. That's just what it says in the reading. So you substitute 0 in there.
Oh yeah, or after subtracting equals 0. Weird.
Yeah, I don't even know
Mine
why
is
they
0,
put that
so
on
it's
there.
what?
I said, I don't really know why they even put that on there.
Yeah, it's okay. All right, square root of okay, so we're doing the square root of, oh shoot. Oh my gosh. 63 plus 27. 296 plus 251. Point 16453. One over 296 plus 1 over 251. Oh gosh. 296. Plus 0.10756. So this is 0.1052. And the thing that stinks is if something is wrong in here, I will never be able to track it down because there's too many
I
components.
know. You have to like go and do it all over again.
Okay, let's do 1 minus 0.16453 equals times 0.16453 times 0.00735 equals square root of that. 0.001033 is 3178. Okay, here's what I got. Z equals 3.32. Is that what you guys got on that number C? Compute the test statistic. I hope.
That's close enough.
Okay, good. I'm not redoing it. I don't care. Huh? Oh, shoot. Okay, I forgot to look in the answer sheet. Okay, p-value. Yeah, I'm happy with it. I do not care. So it's 3.312. P-value I have like way crazy. 9, 2, 6, 3, 2, minus 4. 3, 4. So I have 0.0009.
It should just
the
be
p-value.
0.001.
You just put what?
It should be 0.001.
Value, yeah.
Oh, because I round the 9 to 1. Okay.
Yeah. Awesome.
That works for me. Okay. Shade, yes, I did the shaded. It's there. What decision? So P is 0.00, and we want 0.05, so P is low, reject the null. Yes?
Yeah.
So I'm going to say there is insufficient evidence. I always get messed up on this part. Is that the right one?
No, it should be that there's sufficient evidence to say that there is a difference in the proportion of men who use labels and women who use labels.
Okay. 25% confidence interval. Oh my gosh, for the difference of the two proportions in number 4. What does that mean, difference of the two proportions? There's only one.
Sorry, what?
Did you guys understand that? It's number 5. It says construct a 95% confidence interval for the difference of the two proportions. Does it mean the
Yeah,
two?
so this is where you get the lower bound and upper bound.
Bleh. That's gross.
So that if you use the Excel sheet for this lesson and last lesson, I don't know if you've seen that, but it's on the reading. It gives you all of this if you type in everything.
Oh. I saw it, but I didn't use it.
You should, because it's actually, then you just kind of type things in and it fills it out for you.
Oh, nice.
I didn't use it either, but I just pulled it up right now and I was typing in everything and comparing answers. And
Nice.
Uh-huh. And it's good?
yeah. That matches everything for the homework. So I'm like, why did I go through all of that trying to like do it by hand?
How do you do, categorical data, that one in the sample?
Yeah, the categorical data analysis. It should be an Excel spreadsheet.
Okay.
It makes life a lot easier. Mary, you used it, didn't you?
Yes.
Oh, okay. I love it. Okay, so what if I put in, is it just 1 or 2? Because it has something for X.
We're doing the 2.
That's what I'm saying. It has an X and an N.
Yeah, go down to the bottom and go to 2 proportions, the second tab.
Oh, I didn't see that. Ah! Okay.
Yeah, and then you can plug in X1, N1, X2, N2. And then what kind of test it is.
Let's see. X1, I'm doing 63. And shoot. N1 is 296.
X2 is 27 and N2 is 251.
251. And 95, right? And type of test, we're doing not equal.
Yeah.
Okay. So does it plug in everything else?
Yeah.
Oh my gosh. Okay.
So you should
That is
have,
super cool.
like, for the first sample, it should say 63, then 233.
233,
Yeah.
7, 224.
And then your p-hat 0.213, or p-hat 1, and so
Yeah.
on.
Okay, so is this for our confidence interval? Then we have this 0.045 and 0.166.
Yeah, so 0.045 is the lower bound, and then 0.166 is the upper.
Okay. Good.
It's
And
amazing. It
then-
just made my entire day finding this.
Yeah, I love it. Okay, so we are 95% confident that the number of men and women? Likely to be labeled users lies between 5 and 0.166. Yay! That was ridiculous.
I know.
But okay, it's done.
Until you find the Excel spreadsheet, and then your life is so much easier.
Yeah, totally.
Okay, so let's
Okay.
do the quiz.
Yeah, I'm ready to go on quiz. Start quiz. Okay, I'm going to punch that into my Excel, that loveliness. Where is it? Oh, here it is. Email. So what are we putting in, the yes for the X1? The yes for female?
Oh, man.
Yeah.
Yes.
And then the yes for male is X2, right?
Right.
And then we need the total for female, which is 70. And the total for male is 59. Okay.
So is it 52? That's X1?
Yeah. 52 divided by 70.
52, 70, 42, and 59.
Yeah.
Right?
Okay, got it.
Oh, P1 be proportion of females who can taste. And P2 males who can taste. Yes. Okay. Question. Proportion of females who can taste different from the proportion of males. Okay, so we have P1. Is that in our little Excel table? Or do we have to calculate that out?
No, p-hat 1 is 0.743.
Oh,
Yeah.
I just thought when you said that. Okay, and then it's 0.712 for the second one. Okay, which set of hypotheses is appropriate? So it's equal, and then it's not equal. Is that HO, P1 equals P2 on HA. Oh, the P hat. No, we don't want the P hat.
No, it's just the P1 equals
The
P2.
first one.
Yeah.
The first one.
Okay. Okay, good. 95% P1 minus P2. Point estimate.
Point estimate is always, oh man.
712.
Is that the Z?
I don't know.
I think it's Z.
Which one are you on?
0.394. Let me see, because I still have this, the lesson open. Do I? Oh, shoot. Oh, dang it. Let me pull it up.
Oh man. I swear this goes back to the last lesson.
Oh, shoot. Okay, let me see if I can find it. No, it's not on there. Let me look at my notes from the last one, point estimate.
Okay.
Oh.
P hat is called the point estimate of P. The sample proportion P hat is 1 point on the number. So, but we have more than one P hat, so that doesn't make sense. Or is this when we're supposed to add them together?
Oh my gosh. I'm going to look back in that last lesson.
Well, that's what it says. It says P hat is called the point estimate of P.
So they're saying, what is P hat?
Well, the thing with having two is I think we're supposed to add them together because I remember in, where is it? I think in this lesson it tells you that P hat, the total P hat is adding them together, but let me look.
Yeah, I saw that too, but I want to find out where it is. Let me go back one.
Yeah, so P hat is the overall, it says overall sample proportion. So you add x1 plus x2 over n1 plus n2.
Okay.
I mean, I hope that's right. It just, I mean, it makes sense. It doesn't actually tell you in the lesson. It just tells you in the last one that P hat is a point estimate.
Okay, so
So I'm just going to add them together and put that.
Oh yeah, x1 plus x2 over n1 plus n2, that's what you said.
Yeah.
x1 plus x2.
Which is really just adding both P hat 1 and P hat 2 together.
92 over, where are we? 70 and 59. So I got N13.
You got what?
Does that sound right? I got 0.713.
That's not what I have from just adding them together. Let me
You
look.
got
Well, no, you have to add then divide.
Is that what
because
you
you have
got too,
X1.
Dirk?
Yeah, 0.729.
But don't you add? Okay.
This
Sorry,
is
say
for
it
the
again.
yes one. You have to add them all up. So the male and the female. For the yeses, right?
Uh-huh.
So it's 94 divided by 129.
92 divided by 129 is what I got.
94. It's 94.
Oops. Oh, yeah. Shoot. Thank you, Derek.
You're good.
I even used a calculator on that. Okay, whatever. 94. 0.729. Okay.
So how do we find the margin of error again?
Oh, okay. I have that. But it was from the last lesson, right? Margin of error is these 25%. Do we have the prior estimate? Oh, good. Okay. Z, so it's 1.6. Is that the Z-score? For 95%.
Oh, the z-score is
1.9.
0.394.
95% confidence. Oh. What?
I get what you're saying. I'm confused, Will, because do we use that? We use that z-score or the z-score we have?
Yeah, on question 6, right?
Yeah, I'm confused.
P hat, isn't it? Oh no. I don't know. This is really jamming me up. Is it on our little Excel thing?
No.
Well, on Excel it says 0.394.
Yeah, the z-score.
Yeah.
But I guess for margin of error for 95%, we would probably want to use the 1.96.
Yeah, margin of error is the score, and then square root of, do we have P? My gosh, I don't know how. I don't know. This is all crazy and jumbly. Every time it's jumbly until we get past the lesson and do the test, and then I kind of get it a little bit, but then we're moving on to the next thing. Let's see, margin of error. Let me see if it's in this lesson.
I tried searching it and it's not.
Okay. Yeah, margin of error. Do we have P for this margin of error? P. Then we, oh, I don't even know.
Yeah, I'm honestly super confused.
Yeah, me too. That margin of error is throwing me off because
Oh, yes. I know the formula. That's about it.
But square root of p and then 1 minus p over n. But what is p? That's the thing. So on here we have to figure
Oh,
that
the
out.
p-value is zero. Oh, no, because it's not the
There's two.
p-value. Oh, man.
Z test P1 equals P2. Confidence interval. So okay, maybe we just put that in 0.394. And p-value is 0.6936, yes. Margin of error. So maybe we have to figure it out from confidence interval. Like finding the difference and dividing by 2. Question mark? I don't know. Okay, what is this lesson called? It's called, oh. Shoot.
Doesn't make sense.
It doesn't. Let's see. Okay.
Oh.
Yeah, because all it says is, note that this equation requires us to know the value of p. In most situations, we do not know the value of p. Sometimes we have a prior estimate of the true proportion of successes denoted p star.
Yeah.
It doesn't really help us figure out p. Well, I mean, I guess we could like plug it into, we know the sample size. We could do n, how it says below it, how to figure out the sample size if you don't know if p is available. We'll just have to like go backwards.
Yeah. This is super crazy. Margin of one standard error gives a 68% confidence interval, while the estimate plus or minus 1.96 standard errors is a 95% confidence interval. 0.96. That's the z-score. What? I don't know. I don't really get this at all. Oops. Three, 7. Okay, I don't know.
Did anybody watch the videos?
Said there were no videos for this one, didn't it?
No, it's videos.
It
No, there's
said the
videos.
videos aren't. No, it said the videos aren't up for this one.
It's two videos.
Oh. Really? Notes. He said.
Nope,
Look.
it's up.
Note. the video tutorials have not been updated yet for this lesson. It's on that main page.
I watched them early.
Well, there are videos though, so I'm going to look through them
Yeah.
to see if it tells me what to do.
I'll do the second one. Let's see. This might not be it. It's hypothesis testing.
Everything to the right of plus and minus is the margin of error. Okay, okay. So the confidence interval formula, you know,
Yeah.
everything to the right of the plus and minus sign, so starting with the z-score, is the margin of error.
Oh, we have p hat. Are we just using that? So z-score square root. So 1.96 and then square root p hat. Where's our lovely p hat? Oh, it's the, okay, wait, it's the combined. So is that 0.729? Is that right?
Oh, 1 second.
Yes, 0.729.
Okay, so it's 0.729 and 1 minus. And then what's our n?
What do you mean? It's N1 and N2. So like the whole thing is p hat z-score times the square root of p hat times 1 minus p hat 1 over N1 plus
over
2.
n.
So we use all of those. I don't know what z-score we're supposed to use though.
It's for 95%, so it's, oh, I was thinking 1.96.
1.96.
Yeah, but we just add the N1 and N2 for the whole N?
No, it's N1 plus 2.
Right, and that's our N?
What do you mean? Our N is the N1, which is 70, and then N2 is 59.
Well, we have to do them separate?
It's all in the inputs. So look at your confidence interval equation.
Yeah,
it's
I
everything.
have that, but it just says N, but on here we have N1 and N2. Do we add together for our N?
No, because it's p hat 1 times 1 minus p hat 1 over N1 plus 2 plus p hat 2 times 1 minus p hat 2 over N2 plus 2. So we're using all of it. Are you looking at the right equation?
I see. No, I was looking at my notes from last week's.
Now I know it's all confusing.
Yeah. Okay, so we're, okay, let me, oh my gosh. Where is it in the book? Do you have it in front of you?
Me?
Yeah, do you see it?
Yeah. It's also in the homework if you filled it out.
Oh, I still have it open.
The confidence
Oh, I
interval
did, but it
formula.
never computes. It never computes the same way.
If you pull up the answer sheet, it'll compute it.
Okay, good.
I'm not really sure what to use for the z-score though, so I'm gonna look at the lesson actually.
P1
1. You had 1.
Okay, yeah. So we'll use 1.96.
0.743, 1.96. 1 minus N1 is 70. It's 2. Oh gosh. We got 2.712. And 259 plus 2. Oh my gosh.
Okay, I don't know if mine's right, but I got 0.153.
Okay, I'm not there yet. Hang on a second. Plus
I have 0.154.
square root YLL 60167 times 1.96. Okay, I got 0.152. Does that match anyone?
I got 0.153 and Mary got 0.154. Yours doesn't round up
Oh
anymore?
my gosh. No, mine's supposed to be 0.1519. That's why I rounded it up to 2.
Oh, yeah, mine's
Let's put in each of
0.15259. So,
ours, and then we'll see if any of them come back right.
okay.
Because we can do the second time. Lower bound is negative 1, 2, 3. Upper bound is 185. Hey, bro. Are you okay? Good. It comes with a, okay, what decision? Oh,
I put fail to reject.
P is 0.6. 05, P is low, reject the null. Yeah, fail to reject.
Yes.
Putting 2. Okay. There is sufficient evidence. Yes, is equal.
I thought it was there's insufficient evidence that there's a difference. Yeah, I put D.
Yeah.
What? You guys?
Because
But if
the null is that you're already assuming that it's true. So you're trying to prove that it's not. So you're saying that there's insufficient evidence to suggest that the true proportion is different. You're trying to find evidence. You're trying to find evidence that it's different. You're not finding evidence that it's equal.
Okay, wait, we said reject the null, right? Oh, we said fail to reject.
Uh-huh.
Oh, insufficient evidence. Okay, yes, I agree, it's D.
That's confusing.
No, every time. Okay, all right. Now we got a new one. Oh gosh. P1 is patients who had a heart attack and who died. So for who died, we put it in X1.
Yeah. Do you want the proportion of patients?
And P2.
Oh, weekend and weekday. Okay. So 16713 is the first one, right?
Yeah. Weekday and weekend who died is 6155. And the total for the weekday is 11,859. Weekend is 4,447. All are greater than 10, yes. So I'm putting true. The hypothesis is appropriate for addressing the research question.
I was thinking D.
Is the proportion of patients who have a heart attack and are admitted to die less? Say is equal, first of all, and then less. So I think it's the fourth one.
Yeah, D.
D.
Yeah.
And P hat 1 is 0.141.
Yep.
Yeah.
Good. I got something right, you guys. Number 5, C score is negative 2.020. Get the Z-score from the last question. What should you shade? I think since we've said
Oh, no, it
less
says
than, we
that.
should shade the left.
Yeah.
To the left.
Sorry.
Yeah.
It says it in the reading. I remember it.
Okay, good. What is the p-value? So it's 0.043. And what is the decision? Okay, p is 4, and we want to look at 0.05, so it's low, reject the null.
You
Right.
said the p-value is, did you say the p-value is 0.022?
No, 0.043.
Oh, wait a second. We have to make sure we change the hypothesis test
What?
on the inputs table because it's less than. So the p-value is 0.022.
Yeah. P1 less than P2. Oh, awesome.
Because we have to cut it in half when it's like less than or greater than.
So that was question 18 for 2. Does anything else change that we missed?
No. No, everything
Okay.
else is the same. It's just the p-value. Okay. So we want to say there is sufficient evidence. So it's one of the last two.
I was thinking 6.
Reject the null. There is sufficient evidence to suggest that at least one of the blah blah has a blah blah. Okay. To conclude, the proportion of patients who have a heart attack is less.
Yeah, so C. Right?
Yes.
What?
Yeah. Yeah, is less than.
Gosh. Wait. But B, oh, that says insufficient. Okay. I can learn how to read. Mine, you guys.
Okay.
So over it.
Submit mine.
I got 20 out of 21. That's awesome right there. The one that I missed is number 6. Oh,
The point
that's the
estimate.
crazy one. I can't figure out that
I
What
don't know
was
what
that?
it is, to be honest.
Oh, wait, margin of error. We got that right. I thought that was the one that I missed.
Which one was that? What, number 7?
Number 7 we got right. It's 0.152.
Oh,
Okay.
it's,
Nice.
oh, it's 2 instead of 4.
And then Rosalie,
So
what was number 8?
I got 8 is negative 0.123.
Okay.
Yes.
So when you guys submit yours, tell me if you get number 6 right, because it's not 0.729.
You should just try
I
adding
didn't get
the
it right.
p hat and p hat 1 and p hat 2 together and see if that's what it is.
For question 6.
Yeah.
Oh,
Otherwise, I don't really know how to do it.
Yeah.
6.
Happy with
Trying to see what I
with
mean.
getting 95%.
4, 5.
I mean, unless you guys get the right answer on that one.
So you say you have 7 right?
Uh-huh. Yeah, and it's 0.152. That's what I put.
Well, it says mine is right, and I have 0.154.
Oh,
it's all
I
good.
don't know.
That's what
That'll work.
I put 0.153 and I got it right. So
It's either one.
if it's like close enough, I wonder
Anybody?
if she just like lets it go.
Yeah. Any ideas for that number 6?
Now I'm still looking.
An estimate for 95% confidence interval. Estimate.
You should just guess. It's only one question.
Okay,
No people.
let's see.
Yada, 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 yada. Point estimate.
Point estimate is p hat. That's why we were adding everything together.
But I thought that's what we put, p hat, and it's wrong.
Yeah, but you got a different answer than when I just added p hat 1 and p hat 2 together. That's why I was saying
Oh.
let's try that answer.
Oh,
X plus
shoot.
X2. Bye-bye.
Came up
Yeah,
with
that's it.
0.031, but I can't remember how I got it.
Derek, you got it?
129. I don't know. Like I look in the reading and it says p hat is x1 plus x2 divided by n1 plus n2. So
That's weird.
don't know.
But that's what I'm saying. Add p hat 1 and p hat 2 together because you're just taking x1 divided by n1 plus x2 divided by n2.
No. So
Okay.
Because that's how you find the p hats for both of them, right? X over n.
0.742. 0.712. I'm going to punch in all my answers again. One I got wrong, so I'm going to wait.
Yeah, number 6 I got wrong again.
Dang it.
Just by adding them? Good.
Yeah.
And I'm not going to do it again. We'll just have to ask and see how. I don't know how to do that one.
Okay. 9.185.
So P hat is x1 plus x2 over n and 2.
Yeah. Hold on.
Yeah, I mean, if you guys
Yeah.
want to go back and try to do it on your own.
Yeah, I'm going to make a guess at it, but I have to put in my other ones first. So we're good.
Cool.
All right, what time do we want to meet on Wednesday?
Let me see.
I'm free at the same time.
Yeah, I can do anytime.
I'm available whenever you all are.
All right, so let's just do the same time. We'll do 8 Mountain Standard Time.
Cool.
Okay, awesome.
All right,
Thanks.
bye guys.